Concept 2, graphing linear inequalities in two variables. So we have figured out how to determine if some ordered pair is a solution to a linear inequality. Now we're going to look at how to graph them. Okay, it's very similar to graphing a linear equation, but there's a couple differences. We're going to start by graphing it just as if it was a line, except that if we have a greater than or less than sign in our linear equation, we are going to use a dotted line. All right, and if you remember from when we were doing just single variable inequalities on our number lines, we used an open circle for greater than or less than to indicate that that point that it was on was not a solution. We're going to do the same thing here. We're going to use the dotted line for greater than or less than, and we're going to use a normal solid line if we have a less than or equal to or greater than or equal to. Okay, so start with your equation. This is a greater than or equal to, so I'm going to be using a solid line. And I'll get that set. Alright, and I've made some little cheat points so I can do this faster. But basically you'll graph it the same way. Start at your y-intercepts, my +1, and then you can count up for your slope. And then you'll make your line, which looks something like that. Okay, so that is my line as if this was an equal sign, right? As if this was just an equation rather than an inequality. Okay. The next part is we are going to shade. Let's see if I can get this right. We're going to shade 1/2 of our coordinate plane. Okay, and it's going to depend on our sign whether we're shading above the line or below the line. All right, we're going to shade for wherever our solutions are. So if this y is greater than or equal to everything on this line, right, it's going to be everything above this line because it's greater than. It's y is a greater value. Okay, so we come through, oh, I want big. Okay, we'd come through and we'd shade in our entire left side of my graph. Okay, and that would be my solution set. And it would be anything on this side of the line. Okay? Let's see if I can just get rid of those. Good. Alright. So, now if we had another one, we're looking at y is less than 1/2 x minus 2. So you're going to go through the same process for graphing your equation, graphing your line. All right, I'd go to down 2 and say, okay, I'm going to come up 1 over 2, up 1 over 2, up 1 over 2. And I'd get some points, and then I would graph it. And because this is a less than sign, doesn't have an equals on it, I would be using a dotted line. Okay? And that indicates that if I was going to find a solution, it could not be anything exactly on this line. It would have to be, in this case, less than. Alright? So, it's less than. I'd get out my shading tool again, make all the adjustments to it, and then my y value needs to be less than, so it's going to be under the line, and I would shade all of that in. Okay. All right. Now, if you ever have a problem remembering, okay, wait, which side do I shade? I got my line. I can't remember which side to shade. It's pretty easy to figure out. Just choose any point, right? Any xy value. The origin is generally the easiest, okay, because you're just plugging in zeros. If the solution, right, if the origin, if I choose the origin, let's go ahead and just do one. I have to reset. No, reset. So if I have y is less than 1/2 x minus 2, and I put in 0, 0 for my variables, 1/2 times 0 is 0. I would have 0 is less than -2. That's not a solution, right? 0 is not less than -2. So the origin is not a solution, meaning I need to be shading on the other side, right? Which I did.